Okay, now we need to talk about the properties of exponents, and I'm sorry, this is a typo. It should say rational exponents. We already talked about integer exponents back on the first page. No, first page of this chapter, right here. Those are integers. Now you'll notice these properties, right? So they're the same properties that we're going to be dealing with back here on page 75. Namely, all those other ones still hold true even if they're rational. Not just integers, but they'll work if they're rational too. So let me give you some examples here. Okay, so suppose you have b to a power times b to another power, and they're rational, they're fractions. So if you look up above, it says that p and q are fractions. So let me give you an example. Suppose I have x to the half, excuse me, times x to the let me do 1/3. I think that'd be easier. X to the 4/3. That means that it's x to the, and then it's 1/3 plus 4/3, which makes x to the 5/3. See, you can just add them like you would other numbers. Okay. Okay, so that's saying that you can add the powers. And I'm sorry, I just did this kind of by magic, but I put in some the next rules because they're the same rules we already learned, but I'm going to show you new examples. So if you have b to the p over b to the q, that's b to the p minus q. So let me give you a new example. Suppose that I had x to the 5/3 over x to the 2/3. Let's not do 2/3. That works out too nicely. How about 4/3? There we go. That would be equal to x to the 5/3, which is the numerator power, minus 4/3, which makes x to the 1/3, like that. Okay, now what about the next one? That's the distributive property, that you can take the power p and distribute it from a and b. So let me make up an example here. So suppose I had xy to the, to a fraction power, so like 1/3. That's fine. Okay, so what that would be is x to the 1/3 times y to the 1/3. You can raise each one of them to that 1/3 power. Actually, that would go right in the box. So that's all you can do with that one. They're not like terms, you can't combine them or anything like that stuff. Although terms wouldn't be appropriate here because you're multiplying, but you get my drift. Okay, now you can also distribute the power across division like this. So let me give you an example. So suppose we had, let me think, x over y all to the 1/3 power. Don't mind any of this stuff. Okay, so that would be x to the 1/3 over y to the 1/3. Like that, right? That you can distribute and take each one of them to their own fraction power. I don't know why you'd want to. That kind of makes things messy, but you know, you could do it. Actually, you want to because it helps simplify things if you really want to know. Okay, so then what about the last one? And don't forget, people always confuse 1 and 5 with each other, so be careful with that. If you have x to the, and now we're going to do 1/3 times, or to the, I don't know, 4/3. Just making it up. What would that be? Well, according to this rule, it means you can multiply them. So you'd say 1/3 times 4/3, which would make x to the, everybody remembers the rules, 4 times 1 is 4, 3 times 3 is 9. Oops, should have boxed that. Okay, so there are the rules of exponents again, and they work for fractions just like they did for whole integer numbers. Same rules, they still apply. Poof, I had to bring this up. Okay, so for this example, we need to simplify. We're going to assume that a and b and c are positive, and we've got fraction powers here. So we're going to be mixing fraction powers and whole number powers. It's going to be a grand old time. So, okay, we have 8b to the 6th to the 4/3. Okay, now now see how you got all the stuff in there that you're raising to a power? Then you can use property 3, which is where you distribute that power across the parentheses. So you say, okay, that's 8 to the 4/3, and then b to the 6 to the 4/3. All right. Okay, so you're going to have to do two parts here. You have to deal with the 8, and you have to deal with this guy. So honestly, the b part is actually easier. So for the b part, you're just going to take b to the, and then you go, it's really 6 over 1 times 4/3, and oopsie, and we'll figure that part out, right? It's the multiplying powers thing. So that's not too bad. The 8, on the other hand, is a little bit harder. So, oh, and by the way, that would mean that our b, let's just do the b part right now and get it over with. So the b is going to be, let's see, 3 goes into 6 2 times, so it's b to the 8, because 2 times 4 makes 8. See if this goes, and this goes, oopsie. Oh no, sorry. And it makes it 2, and 2 times 4 is 3, or is 8. So that's why the b to the 8. So the b part's the simple part. The hard part in these is actually the number part. That's where you want to do what we were doing a couple pages ago. Right here, where you're taking things and breaking them down into different pieces. So you want to take, and right here actually, right? So you want to take and do 8 to the 3rd. So you want to do 8, parentheses, 8 to the 1/3 power, and then raise that to the 4th. You're breaking this 4/3 up here to the 3rd and the 4th. You don't have to do it with the b, because the b has this property that's going to work beautifully, right, for when it's a variable. But when it's a number, you're stuck doing the definition of what a rational exponent is. So variables are actually simpler because you have these 5 rules. Numbers are actually trickier. Okay, so what's 8 to the 1/3? Well, we hopefully all know that that's 2. So this is 2 to the 4th. And again, if you don't know that, you can grab a calculator. 8 to the caret, parentheses 1/3, or if you have my calculator type, you can just do 1/3, enter. And you'll get 2 to the 4th, b to the 8th, which we all know is 16, b to the 8th. And you're done. Box it. So we might want to make a note to ourselves. So note, for the variables, use the power rules on this page. The numbers, use the definition on page, let's see, what was it? So page 75 was the properties. I guess I should say properties. I'll change that. The definition of rational exponents. This is honestly the ones where numerator isn't 1, but that's okay. Page 73. So the numbers, you'll have to use the definition on page 73. And then these, you'll have to use properties on this page, right? Which is actually easier, crazy enough. It's the numbers that are harder. There. All right, let's look at letter B. Ooh, all variables. We likey. No big numbers. I guess by numbers I really mean coefficients. I'll be a little bit more clear. Right? So coefficients, i.e. the numbers, the raw numbers, those use the definition on page 73. And the variables use these ones. So this is all variables, so that's easier. So you've got a division, so it's going to be either 2 or 4, but since you don't have that external parentheses, it's got to be 2, where you do the subtraction. So you say, okay, I have b to the -5/9. I think it was -5/9. Yep. Over b to the, and I like retyping these because I want you to see that you can write them either way. So I can write them with kind of the fraction in more fraction form like you guys are used to, or I can write it more as like a division form, like what I put in the notes. All right, now that's equal to, according to our property number 2, it's negative 5/9 minus negative 2/9, which is b to the negative 5/9 plus 2/9, which is b to the negative 3/9. Hopefully everybody remembers that, right? Negative 5 plus 2 makes negative 3, and that's how you add with fractions, which equals b to the negative 1/3, because 3 goes into 3 one time, and 3 goes into 9 3 times. So there's your answer right there, but that's not simplified. You're not allowed to leave negative exponents. That's not considered simplified. So you've got to move it down to be in the denominator, and then when you move it, you get rid of that negative exponent. Right? No negative exponent allowed. So it's 1 over b to the positive 1/3. And I'm going to make this a little bit more vertical, because honestly that's the way we prefer problems are solved anyway. And I know it's a pain, but you're not allowed to leave negative exponents in. So negative 1/3 would still lose a point. You got to rewrite it like a fraction. All right, we can probably fit in C, and that'll be it. So let's do C. Let me type this up. There we go. And again, you can write it more kind of fraction with number over number. You can write it more as division. Now, this, according to our property number 1, is where you just add the two powers. So this is b to the 3/5 plus 7/8. Uh-oh. They don't have the same denominator. That's going to be much harder than the ones I showed you here. Look, the ones I showed you in these examples had the same denominator, 1/3 and 4/3, 5/3 and 4/3, stuff like that. But the one I just gave you here doesn't have the same. Okay, well, if you're going to do that, then you need to multiply. You need to make them have a common denominator, which in this case would be 40, right? So if you multiply the first one by 8 over 8 times 3/5, oops, 3/5, sorry. And then the next one you multiply by 5 over 5. Now you can do that, of course, because you're really multiplying by 1, and 1 just changes the way the fraction looks. It doesn't really change what the fraction is. So this is b to the 24 over 40 plus 35 over 40, right? And again, that's a least common denominator thing. You learned that way back 2 classes ago, probably in pre-algebra. Equals, and that gives you, now with fractions, you just add them up. If they've got the same denominator, which these do, that means your denominator will be 40. So if you have 24 40ths plus 35 more 40ths, that gives you 59 40ths. And there you go. Now the calculator can also help you with the fraction. If you don't want to do it by hand, if you don't want to multiply this step, basically, if you want to get out of this step, the calculator can help you with that. By the way, the calculator can also help you find the common denominator. If you press Math, and I think it's over in the number menu, at the very bottom, there it is. I think it's the least common multiple. I think that's the one. 8. Let's check it out. Least common multiple, 5, 8. There you go, 40, just like I said it was. So that's a way you can help. It'll only do it for 2 numbers, but it helps. But now the fraction part. So you want to take 3 divided by 5. You want to add to it 7 divided by 8. Now if you do this, it's just going to give you this decimal. But if you press Math number 1, it'll take that decimal answer, ANS stands for answer, and change it, that's the triangle, to a fraction. And there you go, 59 over 40. So that's how to get your calculator to help you. You can actually do it as all at once. 3 over 5 plus 7 over 8, Math 1, enter. And we're done with that one.